Hey, Samantha Nakamoto. I can see your messages. Hopefully, you guys can hear me okay. Let me go dropping over to here. Yeah, so we're going to finish up what we were talking about yesterday. So, anybody that missed yesterday, this is part two of kind of a talk about getting into the Linux field. And specifically, one of the things I want to talk about before I get back into my little lecture thing that we were doing is one of the guys asked me after the stream yesterday on the YouTube side, they asked me a question. I said, hey, I'll put that together and put it up in the Discord. So what I did was I put together, he said that he had kind of missed what I was doing with my home lab environment because we were working in one of the nodes here. And what had happened was we had downloaded some software. Oops. And when we had jumped into the server, we didn't have the software when we went to build a box in the Proxmox server that I had. So I was over on the Proxmox server, and I said, go ahead and create a VM. And when we went to the OS, the ISO that we wanted right here wasn't there, even though we could see it right here, right? So what I did was I fixed it real quick, and then he had asked a question about what I was doing. So I did a little write-up for him, and I thought I'd show you guys kind of the little what I did. So there are two servers in my environment. They look like this. There is Hostbox. It's not Hostbox 1, it's just Hostbox. Let me fix his name there. And Hostbox exists at 192.168.11.200. It's been around forever. And when I first built the Proxmox server, I mounted that ISO directory that is being NFS shared out to a directory inside of Proxmox right here, varlib vz template ISO. And if you mount anything over that, well, strictly speaking, you're supposed to put things in there, but you're supposed to load things or put them directly in there. But what I'm doing is using an NFS share in my server and then just mounting the ISOs from another server directly over this location that Proxmox uses to get that. So that's all I was doing. So what had happened was my old original system was Hostbox, and that's what was mounted. So there were all these other ISOs that looked like what I wanted, but they weren't the right ones. We were actually over on Hostbox 2, which is 192.168.11.205, so not 200. And currently that is correct. So I fixed that last night. And the way I did that was I just unmounted with umount that directory. The device was busy, so I had to do a umount lazy. And then I remounted it with the right info. And when I did that, now immediately that file that we wanted, which it wasn't the right version of Jesse or whatever Linux that we were using anyways. So so we're not going to use it anyways. But the point is, we could find why it was the way it was and what was going on in the environment. So that's a little write-up. I put it in the Discord here. So if anybody's like, hey, what's going on in Discord? I think I put it in Home Lab because maybe I didn't put it in Home Lab. I put it in YouTube questions. So they asked a question. I said he asked a pretty good question over there. So this is what I did, and I showed where it was mounted, and then I show that same drawing there of how it was connected and then how it's now connected. How's it going, Agent 57? Hopefully this stuff's useful to you. Yeah, we're just we're going to continue the talk that we were doing yesterday, but I thought I'd show you guys that that's kind of how that works in the home lab. Also, we were looking at monitoring a little bit to make sure that everything looked clean like we kind of expected it to. Oh, I thought I heard a storm outside, but it's just the trash cans getting drug in, so I'll move this over here. There was a storm this morning in Phoenix, but it's still got to 82 or something today, so it's still kind of warm. All right. Anyway, so let's go down here. Where were we at yesterday? We got to pretty much benchmarking. So what we were talking about, for just as a quick recap for anybody, in Linux Systems Administration, we talked through things that admins have to know how to do. We talked about what we do, how we observe, benchmark, and tune systems. We talked about looking at utilization, saturation, and errors of systems. And then I just showed you guys a bunch of tools. And then we talked about how we test things. And then we had gotten down to benchmarking. In fact, I had just kind of explained what benchmarking was when we when we got done talking yesterday. I think the wife came home and I had to drop off or something. So again, this is kind of just a continuation of yesterday. So we come over here and, you know, we're talking about baselining as kind of the system exists in day in the life, and then benchmarking is we want to test some of the upper limits of system capabilities. Maybe we want to run the system at 85% for X amount of weeks. This is very, very common in government systems. When we do what's called acceptance testing for the government, we will write everything down, give them all their STIGs, there'll be all these other things, and then there'll be an acceptance testing phase where we prove that the system can work the things it's able to do. It's very similar to if you guys have ever seen a system like a car get up on a dynamo and then they actually hit the gas on it to see, so you know how many RPMs the car is running because you've got all this electrical stuff hooked up to it, and then you also are tracking the to the ground horsepower of how much it's moving these wheels, these big metal wheels, and how fast it can go, and acceleration, all these things. There's all these things that can be tested. Well, we kind of do that same thing in the systems world, especially with systems that we're doing what's called acceptance testing on, right? In fact, I mean to one of these days, I have it in my notes to put together some acceptance testing procedures for you guys to see in like the Killer Coda labs, right? You can walk through and say, hey, these were the standards, these were the things that we have to do for the system, and we're going to run these acceptance tests and validate. We're going to prove to the customer that the things work according to the test parameters that we've defined. So that's a common thing that I do in systems. Because again, it's not just, hey, trust me, bro, I'm the Linux guy. It's you got to trust but verify, right? That's how the government works on pretty much everything. So benchmarking has this iterative methodology to it where we plan what we're going to do. Maybe we have some goals and we identify what we want to do with the system. So we're going to add extra disks in my example from yesterday. We're going to add extra disks into more of our JBODs, just a bunch of disk arrays, and we expect then to add that to the GPFS cluster, and we should see immediately more storage because we've added more disks. But also because of the additional channel paths, we should see a 16% improvement, let's say. That's kind of what we've planned. We've talked to the vendor. We know that we should expect that. We've done a little bit of cocktail math on what the pathing is and the, maybe fiber channel over Ethernet, and we know what kind of speeds we should be getting. And we say this is about what we expect, right? Then we identify our tools and our metrics for what we're going to do to gather that. So are we going to use DD? DD is a tool that allows us to write out from individual nodes. So maybe we're saying, well, one of the tools and metrics, one of the tools we're going to use will be DD, and the metrics we'll gather is maybe small block writes. I always do small, medium, and large block writes. And you say, well, what's small, medium, and large? I mean, could be anything, right? We were talking about yesterday, is one a big number? One time getting shot is a big number, but one time eating ice cream is not that big of a number. Some people have eaten millions of ice creams, right? Well, where I'm going with that is probably not very healthy to have millions of ice creams, but I'm sure some people are approaching that. Where I'm going with that, though, is tools and metrics are, you look at a system okay, so a small write would be smaller than the block size of the file system. So, a common metric or a common file system nowadays would be like a 4 megabyte block size, right? And let's say that's what your GPFS is running. I think that's pretty common back in the day. They're probably bigger nowadays, but let's say it's 64. Was it kilobytes or? I think they're megabytes now. Anyways, but they're bigger. And the point is, like, you're going to do a whole bunch of really small writes to that to see how it handles that. And then you're going to do a bunch of medium-sized writes, which are writes that are, we're going to have these tests here in a minute where you're going to see them, what I'm talking about. And then you have large writes, which are bigger than block sizes. So that means the file system has to carve them up and put them in multiple locations and add more inodes and do all these things. So if you're testing the behavior of the file system beyond just what you could read in a white paper, if that makes sense. It's that example that we almost always talk about, one test is worth 1,000 expert opinions. I think it should go faster, and on paper it should go faster, but if I do all these things to it and it doesn't go faster, well, that's the actual outcome. It doesn't matter what my math says, and it doesn't matter what me as an expert and any other numbers of experts said. It matters what the test shows, right? The data are the most important thing. All right, and then we talk about planning and resource allocation. You should be doing this around the same time. You should be doing it within the constraints of the system, right? You can't just go modifying systems willy-nilly. So, you're probably planning an upgrade, so you might as well get a baseline before you do that. And then when you switch it over and test it again, then you can test to make sure that there is an improvement or a whatever the state of the system is, we can just see it, right? Then there's the experiment phase. We do the experiment definition. Well, we're going to add disks to the system. We had to do that anyways for storage, but we can still define that as an experiment. Then we say before we do it, we're going to do small, medium, and large disk writes from one node. Then we're also going to do it from 10 nodes at the same time to ensure that the file system can handle it in a parallelized fashion. And then we do the experiment execution before we do the change, right? And then we do the experiment result analysis, and we decide, did we get the outcomes that we expect, right? So we make whatever change that we had to, and then we see that the results were what we expected. We check for what's called the delta, little triangle symbol. There's a delta. And then the improve phase, we do the benchmark report. We do our improvement planning. How do we think we can make this better? Again, you already knew you were doing this. And in my example, we knew we had to get more space. So then we were testing to see if we got the speeds that we also expected to come along with it. And then we monitor the improvement and make sure that it doesn't degrade over time. There's a thing that actually happens with file systems where you've filled up storage of, like, let's say 66% across multiple disks, and then you add 2 more disks in, and then all the new writes, and this is the thing that happens often in, like, GPFS, all the new writes are going to be spread across all of them, so they're going to see speed increases. But older reads, so reads of older data before that change, are only going to be on those first 8, let's say, and then not the 2 new ones. So what we do a lot of times in file systems is a thing called a rebalance. We were at 66% across the board, and all archival data is only on those older disks, but those 2 new ones are at 0, and they're going to get written to at about the same rate as the other ones, because it's typically round robin or some other protocol on the back end. And what we end up doing is we rebalance them. So now they were all at 66%. They moved some of their data over to here, and they're all at, like, let's say closer to like 58% or something, probably when they've moved their data to the other ones. Now, reads are also improved speed, because reads aren't just coming off of the old disk arrays, and they're now across all of them, but also writes are improved speed as well. So that's the thing that we end up doing. And typically there's a cost to rebalance. I used to work on a system that had, we'd be up in the petabytes of data, right? And when you go to rebalance that can take weeks. So depending on how much data are going to have to move into the new systems, it can take a long time to rebalance disks. So it's a consideration, right? You say, hey, we expect, we did our and by the way, you don't do your improvement testing while the rebalance is happening. You can't do that. You have to do it after everything settles back and the system is back like you expect. So that's benchmark methodology. Benchmark tools for networks. iPerf. iPerf is a great one. I use an example sometimes. I tell you guys about how I was working on a project. I was working for Redline, but I was working on a project for a big college in the Northwest, and my boss called me up one day and said, "Hey Scott, you got some time over lunch?" And I was like, "Well, yeah, I guess so." And he goes, "Yeah, all right." And he's like sitting there crunching. I can hear him eating a salad, and he's like, "Let's figure this out." So I'll explain the experiment in a second here, but Kevin said, really good RAID controllers or cabinets that just with their own controls will rebalance on their own, but yes, it will take a long time. Yeah, it does take time. Yeah. And in GPFS, you have to explicitly tell it to do it. I know that because I've had to do that before. Also, GPFS is the only file system that I've ever used that's on the network that I've ever run out of inodes, and I've run out of inodes twice. And then it's got a pretty good mechanism for adding more, but you have to trade off storage. So it's an interesting thing there. Anyways, where I'm going with that is, so this is what me and my boss did. So we had a customer, and it's funny. We call this the customer that shall not be named. That's actually our official company stance on it. It's kind of funny. We don't talk about who it is, but they do something similar to one of our other projects. So we do a government work, and then we do like a downstream company that is working off of that government information that's publicly released, and we support both of the high performance compute, right? And it's not a conflict or anything because, it's all above board and that. But where I'm going with that is that customer that shall not be named, they were paying for 2 lines into their business. They were both 10. They were paying for, I want to say 2 10 gig links. Yeah, they were paying for 2 10 gig fiber links into their network. But they had done due diligence. They did not have an incumbent and a competitor carrier, right? Like you guys have heard me talk about that. If you don't do data center stuff, don't worry about that. But they had a 2 different incumbent carriers coming in, and one was their primary link, and the other was their backup. So on their primary link, it was well tested. They knew they were getting 10 gigabits per second. But they had never flipped over to the secondary link, or they had flipped over to the secondary link and had some problems actually. And they just wanted to validate, they wanted us to validate that they were getting 10 gigabits per second. I think I said bytes earlier, but it's gigabits per second down on that other network link. So me and my boss, we hop on, again, for lunch, right? We're on lunch doing this. And we spin up a VM out in an AWS instance, an EC2 instance out in the cloud. You have to, if you go to AWS, right? So I'll show you guys this real quick. AWS. Right? Now, you might just say, Scott, you just threw a couple micros down and tested. No, you actually have to spend a little time understanding how networking works in EC2. You're not going to get 10 gigabits per second to a small micro instance. You have to pay a slightly bigger, I think it's medium, but we can check, to get to that. And they have it all, it's all out here. But the specific instances, the general purpose and some of these other ones don't have it, but the memory and some of these other ones do. So here's the ones that, so to get up to 10 gigabit, I think we did have to run like a C5 large. Now, hold on a second. Some of you are going to go, Scott, but you were going from 14 cents an hour to that's like almost $2 an hour. Yeah, remember I told you we did this over lunch, so it was only up for 1 hour to do our testing. Well, we got a network. We took the smallest device that we could in EC2 instances that had the ability to do 10 gigabit links, right? And yeah, it was like a C5 large or something like this, right? And that is, I think if that's the cost right there, it's like 75 cents an hour to run. Something reasonable, but much bigger than like a micro, right? And then what we did was we flipped their network. So my boss had the ability to get into their network and flip one of the nodes over to using the routing through the backup interface. And then what we did was we just turned on iPerf. So iPerf works like this. You set the servers up like a catcher and a pitcher, if you want to think of it like that. And what we did was we set the server that was the customer site to throw data up into the server that we had up in EC2. So up in our EC2 instance, we said, okay, turn on iPerf 3-S, so your server, and you will listen on port 5201. And you're just going to sit there and listen to anybody that can throw data at your IP address, right? And we limited our subnets to allow traffic in from only the range that we wanted. So even if somebody happened to scan and happened to find us listening on 5201, we weren't going to mess up nothing was getting past our network to get to that box, right? And then we sat down there and we threw data from, and this is an example internal, but it was iPerf 3 connect out to the public DNS that we had on our EC2 instance, right? And what we were able to do, actually, our initial testing was kind of slow, and we were like, ooh, are they not getting their 10 gigs? And then we said, wait a minute, hold on, let's thread this out, because possibly this backup link is set up a different way. And we threaded it out with like 32 UDP connections, and we got to the max of our, and this is smaller, this is a smaller thing here, but we got all the way right at about our 10 gigabits per second. So we were able to prove over the course of an hour, while my boss was crunching a salad in my ear, on a project that I didn't even work on at the time. I work on that project now because it's in Phoenix, where I live, in the same data center that I do other stuff with. But in like an hour, he and I were able to go close out some loop on some project he was trying to figure out and prove that our customer was getting the speed that they wanted to on this other line. Well, I mean, I don't strictly do networking anymore, and I don't think he's ever strictly been a networking guy. I mean, he's our CTO, so he knows a lot of stuff, but he and I just kind of sat down and hammered this out and proved. I mean, we knew the other one was fast too, but we also used that as a control, and we tested that line too, found it was exactly 10 gigs. Then we flipped it over, tested this, and found that it was 10 gigs as well. However, with the caveat, we had to use more spread out connections. I never really dug into why that was, but we did prove that their bandwidth was the same between the two links, right? So, and then we turn that box off, and it's funny, I still get an alert from my work email, because he and I set up a budget for AWS that says, like, if we go over like $8 or something, it's like a $10 budget, but then 80%, and that thing like alerts me like every month because of other things that we're doing in there or whatever. But it's just like a nice little thing that we did. So anyways, my point is, you use these tools to test, and yeah, sometimes you just use them to test to make sure that your systems are getting the speed between them that you expect. And this can show you all kinds of things. But iPerf 3 specifically is a great tool for testing speed between servers. All right, and that's network actual throughput speed, right? You could use perf. So perf will give you performance statistics about a specific command. So in this case, I said perf stat, and then I did the command pwd, which is just where am I at in the Linux box. And it showed me a breakdown of everything that was happening. And you can do this against compiled code that you have, or executables that you've downloaded and decided to run, to see what they're doing in the system. This is a little more, this is the same type of data that we read when we use the time command. However, it's giving you much more information up here that can help you to find if there's actually, we use this sometimes for if we suspect there's memory errors on a box but nothing's being reported, because in heavy density memory boxes, like we're talking 512 gigs and above, it's possible that some RAM is, I guess the technical term that we use is kind of like misbehaving, and the RAM cannot be failed yet. Like, it's not failing completely yet, but it's not behaving within the 5% tolerance that we need for our systems. And I think I've told you guys that before. If you're 5% over or 5% under the processing speed that we need in our CPUs, we yank you out and the vendor has to fix it. We have contracts on all that stuff for our projects. But that's a pretty standard thing in high performance compute, because you couldn't, think about it. If you had, again, a drag racer going down the track and one of the wheels is going 100 and all the other wheels are going 105, that's not a good thing, right? That's not great. Hey Rob, how's it going? I didn't actually pop in on you today, Rob, so I don't know what you were doing. Last time I saw you, I think it was yesterday, and you were walking around the apartment complex or something. So I appreciate you stopping by, dropping your people off. I know you're probably getting ready to run, but for people that aren't familiar with what I do, I run a professional Linux users group. I try to teach people about Linux and getting into Linux roles. I do all kinds of other things around here too, but mostly Linux. So yeah, thanks for coming by, Rob, for sure. No, I did actually, I did see you a little bit on earlier. I was popping through channels and you were in a meeting, so you were muted. That's what it was. But anyway, so anybody that gets here late, this started yesterday on stream and I've just been going through it. But this is kind of like my Linux systems administration talk. I have like 20 of these, but this is one that's up in our Discord and stuff, and it's about like admin tasks you're going to run into, what we do as administrators, how we look at resources and systems, how we think about those and what those commands are, right? And then how we think about the big four. The big four are CPU, memory, disk, and network. Those four things exist on all systems that we run, right? I focus almost exclusively on high performance compute, but that's not to say that's that important. At the end of the day, it's still a Linux box that we're interacting with, right? We had talked about, there's all these other things that we want to look at and run. SV Laz, thanks for the follow. Hopefully this stuff's useful to you. Observability, things about the system. And then we got into like testing methodologies, how I do testing, how I if you ever see any test I've ever written for anything, I always follow this. These are the 5 things I always have there. And I gave an example for that. SV Laz said, hi, what do you think about AI stuff? I am a lot of people, we just were talking in the Discord yesterday about 30,000 people getting laid off at Oracle and this, and I'm like, well, I think that sometimes people will look at clouds and think, oh, here comes the rainstorm, it's going to be terrible. And some people look at the clouds and go, well, this is an opportunity for this and this. So I don't think it's going to affect admins and engineers nearly as much. I mean, obviously there's things going on, and obviously some people are being affected currently and that kind of stuff. But I think that every time something like this has happened, like new stuff is coming into the industry, things are changing the way analytics are happening, and all these other things have changed for how people code, right? Like I can just go and I'm not like a professional coder, but I can put stuff together. One of my buddies, Midnight Simon, sits around and vibe codes during the day and builds his little TypeBlazer site out, which is kind of like TypeBlazer. If you or Type Racer, if you guys have ever heard of Type Racer, it's like that. It's a site where people go and race and do all this other stuff. Where I'm going with that is, I just think there's still sysadmin work out there. I really do. I think I'm positive there's high performance compute engineering work out there, which is really where I want to get a lot of people is into Linux engineering, but we have to kind of start at Linux administration. If people haven't done administration, I can't really talk to. I mean, yeah, I could show them how to build servers out and stuff, but all the stuff they're going to be doing and checking and testing are things that they would have kind of skills they would have forged over in the realm of being a sysadmin. So that's why we focus on sysadmin stuff. But we do talk a lot about engineering and that kind of stuff as well. And then SV Lazzy asked the same question over on YouTube. That's good. But yeah, so this is my testing outline, and then we got into benchmarking, and we were just right here when you guys came in. We had just finished this, and I think we were down in iPerf, and I was telling a little story about how me and my chief technology officer were working through iPerf to test the speed of one of our customers' network links. We didn't have control of that network link. We couldn't like call up the vendor and say, hey, can you validate this for us? They had already done that. They were asking us, hey, from the like boots on the ground, can you validate that this speed is what we expect? So if we ever have to fail over from our primary to our secondary, that we get the speed that we expect. And that's what we were trying to prove. Any idea if there's jobs related to architecture, structural analysis, and statistical analysis related things? I mean, I just typically tell people go to DICE and go to monster.com and those kind of things, jobbing.com, those kind of things. The probably deepest, at least statistical engineering stuff that we do and that I try to point people to has to do with like Six Sigma. And there's a fair amount of like really basic statistics in that. And I try to get people to do that because I say even if you're doing, I mean, I don't care what type of engineering you want to get into. Like people use Linux to jump off into digital signal engineering, and they go into storage engineering, and they go into compute and programming. There's all types of engineering people do, but one of the ones that I think will always be important is total quality management, like process improvement type stuff, TCM and Six Sigma. TQM, sorry, total quality management, TQM and Six Sigma. I think those two are like always going to be there. So I don't know about, those specific things that you're asking, but I do think those jobs are still out there, at least when I look around. That's what I see. All right, then we were down in perf actually, when I was talking about, perf stat to see what's going on. This is like a deeper view than like what time would give you. This is the same stuff that time would give you. It's just a little more precise. And then it's also showing you what your system was doing while that program ran, okay? And then here's another one. This is when we're benchmarking between two systems. We can use stress to spin up CPU memory, disk hogs, to test the system under arbitrary load, but stress stays within the system. It's not like iPerf that can send across the line and see what kind of speed you get. If stress is unavailable, there are CPU stressing alternatives. We could do something like this with just taking random bits off of the processor. So dev random will just generate random ones and zeros. Then we can do block size and count. We can bzip that up and throw it into dev null. And if you do this, this will just cause your processor to make random numbers, compress it at the highest compression, and then throw it in the trash can. So it's just basically generating a bunch of things, crumpling it up, throwing it away. But this will spin your CPU up to do it. And in this case, this box that I was testing this on, it was doing, this is 2 gigs of just random numbers. And then it was compressing them and throwing them away. And it took it 5 minutes and 9 seconds to do. So that was quite a bit of churning for that. Seabear, you're back. How's it going? I haven't seen you in a while. Currently working in Server 2019. I am a blacksmith of my job, hired as help desk, but I hope to get into sysadmin work. I have worked in Windows Server. My IT career, I've taken Linux through RWX Rob and me. Okay, good. College and fell in love with it. Worked in SSH recently to diagnose network issues. Love systems engineering and systems. Yeah, SRE is site reliability engineering. Is Linux the key to that career? I think of, and this is going to be kind of silly to some of you, but if you've never been in a band or if you've never played an instrument, just kind of check out on what I'm going to talk about for the next 2 minutes. But if you have ever played music or really like had a good music teacher that like showed you guys around, didn't just like, make you play the recorder and say, get out of my classroom or whatever. I grew up playing piano. So I think of the piano as like the basis of like all other, like if you know somebody who sings, they probably sing at a keyboard. If you know somebody who plays guitar but they write music, they probably do that at a keyboard. And I think of Linux the same way, in that all types of engineering fields spin off of us, right? Like in open source communities and just all these things. So to answer that question, I do think Linux is a great foundation. Even if you tell me, Scott, I love Linux, I love doing it as a hobby, but you know what? I'm gonna go be one of those Six Sigma black belts, and I'm gonna do process engineering for big companies and improve the way that we build widgets or whatever. I say, that's wonderful. Nobody says you guys have to work in Linux if you don't want to. I just think Linux is a fantastic base for all other types of things that you can do in your career. Kevin, what's going on over here? Lean Agile's hot. Yeah, I know a lot of people who have made good careers. I actually have a buddy who's a trainer directly for ITIL. So ITIL is one of the ways that we take IT, and instead of being the backup, it's not backup operator from hell, it's the bastard operator from hell, right? I thought it was backup the other day and somebody laughed at me. I was like, I forgot he's the bastard operator from hell. You can't run a company like that anymore. You'll get fired. So ITIL is a way that we kind of turn what we do as IT into like a service. We come out and like give a menu to people and say, what would you like? And here are our service level agreements. If you order this server, we'll get it to you within 48 minutes or something. That's kind of slow nowadays, but back in the day, we used to get servers to people in like four days. If they ordered physical servers, that was like 3 weeks or more. So like the time has come down. I can get servers to most people from the time they push a button in under 5 minutes. They'll be getting an email that says your server's ready, here's how you connect. And that's not hard to do anymore nowadays. Anyways, Kevin said, had a coworker compliment me on an outage where I was driving the call as we figured out the cause of the outage and we would fix it. Yeah, Kevin, I'm one of the few guys I know that just like hops in and I'll run a meeting with like 20 people on it and I'll just have my screen up. I have a few other good coworkers that'll also do that. And I tell people like, well, what are they going to do? Most people, the screen's scrolling by so fast they don't know what's going on in Linux anyways. So I don't mind doing that in front of people. Being the one on call to organize folks, not getting freaked out. How you do that really matters. Yeah, and I'm a big fan of practicing your incident response. I was saying yesterday, you need to know your commands, guys. You can't go figuring this stuff out when you're in the middle. You shouldn't learn. There's a great example. I think IT Crowd is a great example anyways, but Moss is trying to put out a fire, and he picks up the fire extinguisher, and he goes like he's going to use it, and he goes, And he sits down, he starts reading how to do the fire extinguisher, and it's like, that's not the time to figure out how to work a fire extinguisher when the fire's literally burning on the desk over there. And then there's a whole gag about how it was made in the UK, so it starts on fire, and he looks at it and goes, I'll just put this fire over with the rest of the fire. It's pretty funny. Hector, thanks for the bits. I appreciate that. Seabear, is this going to be on YouTube? Yeah, this is on YouTube. Yeah, I always stream to both. Is this going to be on YouTube? I heard nothing when you said about being in a band and responded to message. Oh yeah, Seabear, I was just saying that I think Linux is the base foundation for a lot of things in engineering, and I think that it's a great place to base your career on. Much like how like somebody who plays the piano or anybody who's in a band typically writes their songs sitting at a piano. That's just the kind of thing. IT Crowd was so funny. I thought there were so many funny things in that show. Yeah, and it's not always speed; it's the consistency. That's true. And ITIL is a fantastic foundation. I tell people, this is one of the things that like I got asked a question when I took I have an ITIL version 3 certification. I don't even have that like on my resume anywhere because I didn't really care. And they're up on ITIL 4 now. But to that point, Kevin, I got asked a question in that meeting that I use as an example still to this day. The guy said, "What do you guys all want to take out of this?" And when he got to me, I said, "Honestly, I'm an engineer. The only thing I want to take out of this ITIL, the only thing I want out of this training is to do it well enough that I'm like the guy surfing on top of the wave, not the guy getting tumbled underneath the wave." And what I mean by that is if you guys have ever seen somebody surfing, when they're surfing on top of the wave, they look cool. It's like the wind's blowing in their hair. They're getting the spray. They're in the little green room or whatever, and that's like all the cool stuff. But have you ever seen somebody wipe out on a surfboard? I have. And they're down there tumbling underneath the water, hoping they come up one day. Well, that is how your engineering career is going to be. If you don't figure out how to do your processes and your procedures in your company, you're going to be that guy getting his ass kicked under the rock because you have to do it anyways. So this is something I learned in the Army. I got to do it anyway. So why am I going to sit around and complain about it? So I told the guy, I just want to know enough to ride over the top of this stuff and not let this, because I know a lot of engineers that spend their day pissed off because they have to do stuff that you're going to have to do it anyway. So why be pissed off about it, right? And obviously we can argue about that, but I'm saying like the business processes are there for a reason. And to that point, ITIL is a fantastic thing to understand, but you don't have to be like rigorous about how you hold it. Like we always do it this way. No, it's just, I should understand the process so my life's easier. Everything I do as an engineer when I'm building stuff is to be able to build stuff. And if somebody's got some other process or something that I think is annoying, I just figure out a way to get around it as quickly as possible. If I hate writing stuff up in objectives and in like ServiceNow tickets, I just have templates of everything in my notepad. I have templates over here. Like I could show you. You guys think I'm kidding? I have templates like when I talk to my college students. Like here's my student email templates. Like things that like if I'm talking to my students, here's like unit 4, we're up in unit 5 now, right? And I have like all the things that and I modify it each time I send stuff, so there's a little bit of personalization to it and this, but it's like in general I just keep templates of things, and then that makes my life easier. Templatizing things makes everything easier anyways. But all right, so anyways, benchmarking tools, more of them. DD is a great one for reads, writes out of a file system or down into a file system or to a disparate node. You want to test the speed of something. This is one way to do it. Typically, we write to a new name of file because some file systems will cache names and just be like, oh, this is just a bunch of zeros, and then you'll get false data back. So we always write to a new name. So this is a way to use DD. I show you guys that all the time. And then we can read from a file system to see how fast we read data back out, right? We did that yesterday a little bit, messing around. So this is like practical application, right? So maybe I gather current information. I have a table for 2 servers, the Hellcat 1 and the Hellcat 5 server, right? And they have, we have disk write optimized per block. So that's like that's a mid-sized write. Then we have disk write at 1024K, so that's smaller typically, so that's a small write. And then we did reads, and then we did disk rebalance percentage of, or amount of gigs, right? And how long it took to rebalance or something between these 2 nodes. Then I make some plan change to improve the system in some way. In my case, I was adding a bunch of disks into these JBODs and adding more channel paths for writing into the file system. So I was expecting to get higher speed. So then we gather new information after the change. And after the change, I see that the write took less time. It took only 8.5 seconds, so that's about a 20% improvement, not quite, but right about 20%. And then the write on smaller blocks was about a 33% increase of speed, right? Or another way to say that it was decreased by about 33%, right? And then disk reads, I didn't capture that data, so maybe that's probably lost forever now. But then also my disk rebalance of 100 gigs that I was moving across the file systems took only 4 minutes instead of 5 minutes. I don't know, right? These are actually made up numbers that I did, but this is very similar to something I did when I was a high performance compute administrator. Oh God, like almost 15 years ago at a company called Keras. We were adding new disks in, and what was happening was Okay, so whenever you buy a high performance compute, in this case, they were leasing a 3-rack HPC from IBM, and we had everything set up. I actually came in near the end of the project. It had been set up by IBM, and I was kind of going to be their administrator on it. And it was actually kind of funny. I think I can tell you guys this. Yeah, this isn't breaking any kind of like non-disclosure or anything. But I can tell you this: they got me, and I came in and I like ran the system for a few years. And they told me at one point, one of the managers was like, "Yeah, the only other guy that we had that had made it as far as you in the interviews, we liked you and him, but he was an academic dude out of like Minnesota, and he was only going to move down here and run this for us for $400,000 a year." And I was like, "I'm not making anywhere near that." Right at that time, I for sure wasn't. But it was. I was like, "I'm not." I sold myself short. Anyways, where I'm going with that is. I took over the system, and I forget what I was saying exactly about that, but I was about to tell you guys something with that. But anyways, yeah. So we took over. I ran everything for them, and this was actually something where I was going with that is the way it was built was there was a hot tier, which were all SSDs, and then we had these. It was like our middle tier or our warm tier, where it was large, spinning disk platters. And then we had our slow tier or our archival tier, which was all tape, TSM for the tape and all that kind of stuff. And then there was tape on-site, and then we also had off-site tape as well for compliance and regulatory and HIPAA reasons and all that kind of stuff. Well, what we were finding is the SSD storage, which we thought a lot of stuff was going to reside on. And by the way, it was tiered to move. Like after 2 weeks, if it was an SSD, as it was originally written, we could then move it up into warm storage, and it would stay there for like 60 days before we would move it back to tape. Well, what we found was, and this is kind of to the point what I was talking about, is we added more JBODs of just those disks that were just spinning disks. We were getting massive performance increases, and they were much cheaper than the SSD disks. They were much cheaper, and they were also much bigger capacity. And as we kept making more of them and adding more and more channel paths, we were getting a tremendous amount of performance. Plus, when you first build something, it's the best laid plans of mice and men, right? You plan to, hey, we need this data at this scale. Well, my company found out very quickly that wasn't how we use data. The R&D side of the system, and we ran that system for both testing and our prod. So we had some splits in there, but it was one big system that did everything. A lot of like government stuff will have them split. In this company, we had so my point is we didn't know how data were going to be used in the system when it was first built. As we kind of marched along and figured stuff out, that warm tier was perfectly acceptable. And we saved the company a lot of money by testing and proving, hey, we can just keep buying these. Hell, we can take that SSD tier completely out and just keep stacking just, a bunch of these bricks of spinning disks. Gives us enough performance for what we need, and just gives us a massive amount of more storage for less price, right? So, anyways, that was a little object lesson in it. Template, something like that. Oh yeah, we don't need templates anymore because of bots. Fair. All right, so troubleshooting. Troubleshooting is one that I always go over. And as I show you guys these things, I always tell you this too. The goal of being a good troubleshooter, because you're going to troubleshoot things your whole career, is not about collecting all the troubleshooting techniques you can, like you're collecting Pokemon, and then being like, I have that one Pokemon that I've never pulled out before because he never had like his opposite type, but I can pull him out for this one instance. No. What's better in troubleshooting is to have one or two types of techniques that you use all the time, and you can make them work in any situation. Anyways, that's enough of that. But for sure, let's talk about troubleshooting theory, right? There's many ways to troubleshoot a problem. I learned some different ones in the Army that actually look exactly like this. Most of the time, if you go to college and do engineering school or any type of engineering discipline, they're going to teach you this type of troubleshooting theory, right? I'm not trying to teach you multiple ways of troubleshooting, but to find a few that resonate with you that you can always apply to situations, right? By the way, if anybody's wondering, this is up in our Discord, this talk. So because people were asking yesterday, hey, can I get my hands on that? Everything is in should be Prolog presentations right here, and then this is up here. It's from a couple years ago, but it's I've updated it a few times, but it is right. All this stuff's there if you guys want. Linux Systems Administration. See, and I said, boom, I'm not a liar because I hadn't put this up when I first put that out. But first, we identify a problem and its symptoms, right? So we say, people will tell you, you'll get tickets. The server is acting funny, and you're like, what is it doing? Telling jokes? That's irrelevant, right? No. The system is not responding, or it is giving a 400 error when you try to go to a web page. Well, that is definitely not funny, and that's definitely a problem. Or I try to SSH over and it just hangs and then it fails. Okay, well that is a problem, right? Is it happening for just one user? So the thing we do is we identify the problem and we start to find its symptoms, right? We start to kind of dance around the scope of it. Can I get into the server as the root user? Can I get into the server as my own user? Did the server lose like IDM capabilities to get identity and access management, or like its trust to whatever LDAP server it's using? Is SSSD not running correctly? There's all kinds of things that we might do, but then we establish a theory of probable cause. We say, well, it's probably this, or it's probably that, or it's probably that. And we're going to get there by kind of probing around at what the symptoms are, right? Then we're going to test our theory to determine the cause. So we're going to go and figure out like, oh, hey, yeah, I do an LDAP query and I don't get anything back. Well, that's bad, right? If we're using LDAP. Or I tried to write into this file system and sure enough, that file system's busted. NFS stale mount. Is it here? Are other servers able to get in there? Is this mounted read-only for some reason? I've had boxes. This used to be a problem in RHEL 8 where on certain versions of VMware, the box would just like snap and then it would go to like a read-only mode. And the server would still be up and running, but it couldn't write its logs. It couldn't, there were all kinds of things it couldn't do anymore. And it was ready to just crash, but it was still like kind of moving along for people to get in there and stuff. Hold on. So Seaberry said, for someone who wants to drive into the nuts and bolts of Linux more, would you suggest getting to know more the Linux OS or server or SSH terminal? Seabear, there's a few things that I kind of recommend for people. If you say like, hey, I want to do Linux, right? I want to do Linux professionally. There's a few things I recommend. We have some groups that meet. I don't even run these groups. Bash Study Group is Colchis, as is Linux from Scratch. Linux from Scratch is probably one of the deepest dives into Linux, and it's from a free ebook that's out there, the Linux from Scratch ebook. And people, the guys have been going through that. I think they're on like the second or third session of it. I think this will be their third session this week. But that's a good dive in. But if you say, hey, Scott, I need to understand these tools more and I need to dig in more, we have all kinds of free stuff for that. Let me see. Where do I have this? I had it up yesterday. I don't think I still have it open. Where is this? That's something else. So let's just go to LAC. So this is the all the free stuff that's out there, right? And we have a Linux admin course that we wrote on like how work comes into like an admin. So if you're gonna be an admin, what does the job kind of look like keeping a bunch of servers running? And that's kind of the focus of this. This is for a beginner, but it's also kind of designed to take somebody who's been doing, like a lot of us have done a lot of Linux as hobbyists, right? Like if you're hanging out with me for even a few minutes, you're probably a hobbyist at least. But if you want to go do this stuff professionally, where's that kind of jump? What does the work look like? That kind of stuff. What do I need to know about like package management in the industry? Because what type of problems are going to come from being around that? That's kind of what this is all about here. And then we also have other books. So the Linux security course is around if you want to go build secure Linux systems. This is building to a compliance standard, securing the network, allowing users on, bastion hosts, so like air gapping systems, updating systems and doing patch cycles, that kind of stuff, monitors and parsing logs, monitors and alerting out to other systems, right? Because systems are always closed in. They're closed systems at some level. And then when an alert is like it's like if you've ever boiled tea or something like that, and when the thing starts boiling, it starts whistling. It's something has to alert you that some state has gone beyond what it's supposed to within a closed system, right? So that's monitoring and alerting. We talked about configuration drift because that's the death of good systems administration. If anybody's just willy-nilly changing shit in your system. And then we talked about certificate and key management, and then we kind of had like a final recap and all that stuff. Yeah, sometimes near to go. Yeah. I looked at major incident reports, other similar issues. Sure enough, Windows firewall policy was pushed to a bunch of servers. Yeah, that'll get you. That'll for sure get you. And then the last one, we're actually still making this course. I have the course all done, but this goes up to 16 weeks as well. This is automation tools and tooling that I've run into and things that I've done quite a bit as well. So, but these books are free. They're just out there hanging around. The guys build them with Markdown. So if you want to see how to build those, if you're like, how did the guys build these? You can actually go get involved. The course books repo is right here on GitHub, and it'll show you how they built it. They actually have it all down here. They tell you how they did it. They say what they did and how they put it all together. So it's pretty cool. It's pretty cool watching the guys work. They used to have a meeting, I think, every Saturday or maybe Sunday afternoon. They used to meet, but they've kind of taken a little break. But we'll get back on track. I'm gonna do a HPC course here soon too. So, but troubleshooting theory, right? You walk through, and now this is very high level. I have seen this as an 8-step troubleshooting theory. I've seen this as 7. I've seen it as 6. Typically when it's 6, they push 2 of these together, so the implement and establish are at the same time. But it's at the end of the day, like it's not really important that you memorize these. It's that you understand how to move through the process of finding things. When I go to a server, I've told you guys this before. When I go to a server, and I've not been on this server before, I got to call out in the middle of the night. There's like 3 things I always do on a server. I do an uptime, I do a last, and I pipe it to more to see who's been logging into that box, and then I do typically like cat etc splat release to see what's going on, right? Just like maybe I've never been on this server before, and the guy who normally runs the server is out of town, and I just want to see what's going on. I want to see the uptime. Has the box rebooted recently? Who was logged in, and was it actually a shutdown? Because you'll see if there was a shutdown initiated, you'll see that in there as well. And then the version of it, because maybe it's an older server that was built under a different protocol, and you know, all kinds of things, and you're wiping sleep out of your eyes because it's 3 a.m. and you got called out. Agent forgot to say hi to you before. Yeah, good. These are things I always do on boxes. Like they're like, if you were watching me with like a bridge call and there's like 20 other people over my shoulder, I'll still do those 3 commands because I need to know those things are true before I even start going down any other paths. So a lot of troubleshooting theory for me is I test assumptions and I validate data that I know, and then I throw notes out at all times as I see anything that I find anomalous to the system. Now, one of the things you might say is, well, Scott, how do you know that that's not right? Well, let's say it's 1 server out of 5, you know, and they're all behind a load balancer, and one of them's not working right, but the other 4 are. Well, I actually thought about this. You know, people say comparison is the thief of joy, right? You shouldn't compare yourself to other people. That's probably true, but you should compare servers to other servers because comparison is the best way to see if one of these things is not like the others, right? So that's something to think about. Anyways, all right, so this is troubleshooting. This is a theory. This is it visualized. You start with identifying the problems and the symptoms. So start. You gather information. You go and you write, you know, you do commands. Great commands for figuring out what's going on in the system. I was talking about this yesterday. I always give this guy a shout out every time this comes up. Brendan Gregg has really excellent, if you want to see how Linux is performing, this is just one of the best websites. So I'm going to link this to people that want it. But there's a limitation to what I'm showing you guys right here. And I always give this caveat here. You can't give something like this to the management. You can't give something like this to non-technical people. And even to some extent, you can't give this to even like your developers often, because developers can't run the same commands that you can as an administrator. So this stuff is like our diagnostic tools, and we have to know how these tools work. We don't want to be trying to figure it out late at night. So I would highly advise, if you say, hey Scott, I want to be a good Linux administrator and then eventually become an engineer, you got to know how to go gather information from systems. Because at the end of the day, right, this is you're just staring into an abyss. Right? It's just me sitting at a command line, and I'm like, it's not a real command, but it's like, what? Like, I remember when I was a kid, I had this little TI-80 something little computer from Texas Instruments, and I had these little cartridges that could play games. And there was one game that me and my brothers just hated because it was like a pirate game, and you were like stuck on an island, but you had to say like go north or go south or explore a cave. But me and my brothers were no good at it because we were like 4 and 5, and we were just like, what the heck is this game? But it was all command line stuff. Nowadays, I'd probably love that game because all I do is walk around in the command line all day. Actually, I should go find that game. Let's see real quick. Let's see. On console. See if I can find it. Is there an old? So I've found other games on there from way back in the day. Yeah, these were the commands you could do. It was called Pirate's Adventure. That's exactly it. Yeah, that's funny. I'm gonna have to go. Oh man, we would get killed by pirates so much. Let's go see if I could probably go find that. I bet somebody's ported that over. And then you could go. Yeah, it was this little game like this. You just slid in the thing and then it popped up. Yeah, it was like this. What do you do? And you could say help, and you could like do this stuff. And then here were the things that you could do. Yeah. It was yeah. It was not great for a like 4-year-old to try to figure out. I had a typing game on there that was pretty cool too. Kind of helped me learn how to type. Anyways, you gather information, identify symptoms, like what's not right. You know, is the server supposed to have two interfaces, but it only has one? Is this server supposed to have come up clean, but it doesn't? We looked at a bunch of commands for this yesterday. And since this is technically part 2, we won't go over all those again. But that observe, benchmark, and tune is all part of this, observing the system. And then when we're looking at systems, we're doing utilization, saturation, and errors to see how much of the system is utilized, where's the saturation occurring, like what's hitting high, what's hitting queue time, and then timeouts, and then log errors, and all those kind of things, right? Then we come down here and we establish a theory of probable cause. We question the obvious. Well, should the system be systeming? Yes. Is the system not systeming? No. Go fix it. So sometimes one of the things I like to do is follow the OSI model, right? Can I ping the box? Can I SSH into it? Well, then I don't need to go make sure it's on. I don't need to make sure its cable's plugged in. I don't need to check that its MAC address is good. I don't need to make sure that it's got a gateway set in its routing table. I know all of these things for the first 3 layers are working. So then anyways, so you come down, you test your guess, and probably your guess is right. And then if it's confirmed yes, you go start to fix it. Plan out how you're going to fix it. If you need downtime, if you have to do an emergency change right now to get the system back working, and then document it later, right? Because 2 things that always happen later are, we're going to fix this thing and get it back working, but then we're going to do an emergency change so we know that something changed on the system. And then we're also going to do a root cause analysis to be able to figure out, well, what caused it and how do we... Those are 2 things that shouldn't be happening in the initial call, right? We can be gathering information for that, but that's not as critical as getting the system back running, right? But anyways, if we say we can't figure it out or we don't have the knowledge, this is something I often do, something's changed in the network, or at least nothing's wrong on my side and I can do everything else, but I can't netcat over to another port that I normally can get to. This happened a lot when I used to work at AAA, because we were going to like a lockdown. So security procedures change over time in companies, and they get more, you get more to specific regulations and PCI changes. So now all of your PCI data needs to be in its own network. So now firewalls need to be dropped on in internal networks and stuff. A lot of this stuff is fixed nowadays by just having zero trust. You can't talk to anything unless you're supposed to, but that's neither here nor there. But maybe it's something outside of the visibility of my system, and I need the networking team involved. So I say, hey, we need to get networking on, right? Need to see, like, I went through the changes. I found there was a change earlier tonight, right around when this broke. Nothing is obviously wrong on the system. We need to escalate. So giving up is escalation to somebody else. And escalation is not always saying I can't figure this out. It's just with the tools I have, the thing that's broken does not seem to be on the system. We need to go check elsewhere. I often advise my junior engineers and junior admins for sure, don't just start saying, well, this is obviously the network. Say, hey, this is the data that I have. These are the systems that are still working that are over in that network. These are the systems that no longer are. We know there was a firewall change tonight. Is this port open, right? Like, I'll ask very directed questions because, you don't, I mean, the networking team, there's two things about them. One, they're used to getting blamed. And two, they already know it's their fault. So you don't have to bag on them anymore because then they're going to hate you. PCI is very much a huge pain in the ass, Kevin, that's for sure. And then you stop, or if you get down here and you try to fix it, and then you fix the problem or escalate it, then you verify that the system works. Is the problem solved? No, you have to go all the way back up here. It's like Chutes and Ladders. You land on the wrong one, you got to go all the way back to the beginning. If the problem is solved, yes. And then the question is, could this problem have been prevented? That's a tough one because sometimes, and honestly, this is the thing for the Monday morning. This isn't the thing that's probably happening that night, unless it's something that has to be part of that emergency fix. Do we have to take preventative action? Do we have to do one of two things, guys? There's two things that cause security incidents, and a downtime in a system would be a security incident because it affects availability. But I always say there's two things, man. There's misconfigured systems and misconfigured users. Do I have to fix the system so it doesn't allow it, put guardrails up? Do I have to fix the users by bonking them on the head and telling them they have to do something with a policy? And then I have to write a policy or a procedure, so policies are higher level things that people need to acknowledge, and then they're going to go do what they want. Procedures are things these are the things you're supposed to do on the system, but then policy is only enforceable. Like, if I try to enforce policy, I can't really enforce policy as a Linux admin. What I can do, I can enforce technical controls. I can just say, no, fuck it, you can't be on the system anymore, and lock people out. But if that's not according to what the company wants, then I'm probably going to get fired by not letting people into the servers anymore, right? So what I need to do, and this is where a lot of your consternation is going to come as an admin and engineer, is you're going to be like, all right, guys, we agree, right? And everybody's going to be like, yes, we agree. And then it's going to come time for management to back you up on that thing that you all agreed to with the security team there and with this dev team. And somebody's going to be like, oh, look at those devs. Look at those little puppy dog eyes on them. Those devs don't want to do anything bad. Go ahead and we'll go ahead and lax it this one time. And you're like, motherfucker. Okay, I need it in writing. I need it in writing that you're bypassing your thing, because you're accepting the security risk at that point, not me. But I'm going to tell you, like, a lot of times, and this is real bad with root. People always want root. They're like, just give me root. Just give me a little hit of that root. And then they're like that guy on Breaking Bad that's like breaking up, he's breaking up the Coke with a knife, and then he's like snorting it. And he's like, oh yeah, this is the stuff right here, right? You guys probably know who I'm talking about. And then, anyways, I'm thinking about when they turned him into the MC. They put him in the Marvel universe, right? Crushing up the little the Infinity Stones or whatever. He's like hitting those, and then he's like beating up. Anyways, all right. Unlike puppies, you can actually kick the devs. Yeah, fair. And everybody's like kumbaya and stuff, and it's like, yeah, but if I got to be the only one that's going to be like enforcing the rules around here, that can be painful, guys. If you're the one who, like, they make you as the engineer be the bad guy, it's like, that's not my job. My job isn't to be the bad guy. My job is to build stuff to a standard and then keep it working to a standard. If we always have to lax things, then we either need to change the standard so my stuff doesn't break anymore because of arbitrary things. All right, anyways, I've had some knockdown, drag out fights over the years about this, with even up to C levels, right? And I'm surprised I've never been fired from anywhere, because sometimes, I mean, look, if the standard, if it is a, and I just said if like a million times, but if it is a engineering standard, and they have agreed to, and they have said this, I will hold the line on that, right? Like if it's something like that, it's like, well, no, we're going to get fined by the PCI auditors when this comes up. You are the ones that have tasked me with doing this. I have to do it, right? Like I can't. There's no other option here. But anyways, this troubleshooting visualized. There's a bunch of methodologies and a bunch of things, but any methodology you're going to use has to look at least like this. It has to have a starting point, it has to have some process you always try to follow, and then it has to have an ending point. And then the ABCs of investigation are assume nothing, believe no one, and check everything. This is actually, I've saved quite a few off the rails things before over the years where people are, sitting there and they're going down the route of something. And I'm like, wait a minute, this server looks fine. What server did you guys say? And they're like, oh, it's this server. And you're like, that's not the one that came in the call out. That's not the one that we've been talking about for the last 15 minutes. Yeah, that server is jacked up now that I see it. But the server I've been checking out is fine, and sometimes you have to, like, you assume nothing. I get told all the time, and this is probably the number one call out thing over my career. I would get called all the time or told all the time, the server's down. You go to it, the server's been up 180 days. Back in the day before we patched all the time. This server be up 180 days. That server hasn't gone down. They're like, oh, no, sorry, the service is down. And you're like, well, that's a little different. But you got to understand, a developer or the end user, or especially like people getting the calls, they think of the whole server as the fact that the website's not responding. So you see what I'm saying? Like, they're going to tell you all kinds of things. They're not wrong. Like the service is down, but they told you the server was down, and you're the Linux engineer. You see what I'm saying? Like, people are speaking different languages, and it's kind of your job. As Linux engineers, we're tasked with fixing and knowing everything, right? They're like, you're an expert, you can do everything. But this is how good troubleshooting works. I like to hear that only some Linux commands, but some experience wisdom from you, man. Yeah, well, hopefully that's useful to you. You're always welcome to hang around. I tell people, like, especially when people raid in, I don't know who came from the raid or whatever, but I say, I might not be your favorite, but, if the other person's not around. And Rob's great. By the way, we didn't even give a shout out to Rob, did we? Hold on. Give a shout out to Rob. In case you guys don't follow him, you should. He's doing a boost again too. I think he's back on like week 3 or 4 of a boost. So boosts are like good starting Linux and getting into the industry for people that are trying to do that. So you guys should focus on that if you don't. If you want to be a Linux person, you should focus on that kind of stuff. All right. Another one, logical methodologies. You should create a problem statement. What makes you think there's a performance problem? And by the way, you can just do these quickly in your head. You don't have to like stop the bridge call. You got 20 people on a bridge call doing whatever different things they're doing and say, what makes us think there's a performance problem? No, it could just be we're getting 10 times the number of 404 errors that we used to. And they all seem to be when the connection goes to this one server behind the load balancer, we need to check that server out. Well, that may be something you figure out real quick. But by that point, people might not even know that. They might just know that 20% of web traffic is failing or whatever. But what is behind the load balancer, there's 5 servers, and one of those ones is not accepting connections anymore. Now, by the way, your load balancer should have recognized that, and probably, there's some other things to think about there. But anyways, this is one that comes up. This is a big one that I tell people. This is where administrators have an easier time than engineers in troubleshooting, because engineers, when you say, has the system ever performed well, do you have a baseline? Well, if you're an admin, the server was working 20 minutes before they called you, or about 20 minutes before the alert went off. So that with very minimal changes, this system should be back working. With the right NFS mount, with the right stale mount point fixed, with the storage that had filled up and clearing that out, or clearing caches, or restarting a service, this server should work with the configuration that's on it, barring some kind of catastrophic failure in the hardware, right? But if you're an engineer and you're like troubleshooting something that you're building, you don't have that, because you're building something new. So you want to fail very quickly as an engineer. Like when I'm building stuff, I want to build it over and over and over again until I get a system and then my notes redlined to where I can build that system with the push of one button, right? That's always my goal. What's changed recently? We go look at anything in our configuration management database and our change management logs. Review recent RFCs. Was it patching night, or were guardrails being dropped in with firewalls? This is a huge one that I've run into where, for PCI reasons, they were hardening all these different firewalls in the network, and now all of a sudden everything's busted with our satellite. And this is actually a real example. If you go and you say open ports for rel satellite, right? What are the ports that are needed to run satellite? And now, if you've never seen this before, this is something that you're like, okay, if you're using, and by the way, we were using capsules. So satellite doesn't always deploy to all the nodes. All the nodes don't always pull their RPMs from one satellite in a company. If you got a lot of stuff, you've got disparate systems out there called pods, I think they're called, or you see right here, satellite capsules, right, or whatever they are. But for all of this communication to work, you need 80,443. Those are pretty common. But here's the other ones. You need for a capsule, the QPID dispatch to the QPID dispatch router and satellite. You need 5646 open, 5647, 8000, 8140, 9090. These all have to be open, or it doesn't work anymore. This is some kind of spacing error in the RHEL world. Man, look at that. Look at that guy. That is one of the worst. Somebody needs to fix their shit. Jeez. But anyways, this is directly on the Red Hat documentation too. Wonder if I can. Oh, how did I get dropped over? Anyways, it doesn't matter. But these are the ports that need to be open. And terrible scrolling aside, that's I'm probably on like a different one. And then what version of satellite are you on, right? Anyways, all these things. What's changed in the system? But one of them that happened with us was so the firewall team came in and they dropped all those things, and then we told them, hey, we need this open now so we can do patching. And they said, well, those didn't get grandfathered in. We had a list of all the things that we knew about, and those didn't get grandfathered in. This was actually this is a real conversation I had with my networking team on a call late at night with things broken and we couldn't patch to certain environments. And they go, well, yeah, but we grandfathered in all the ports that we knew about. You guys don't have those. So when we locked down all the ports that had previously been open, we didn't open those ports that you just said you needed. And we said, excuse us, in the CMDB 5 years ago, here's our request for all those ports to be opened before, and we gave that to you. And they're like, well, okay, we didn't go back that far, this and this. You're still not grandfathered in. You need to redo those requests. And we're like, it's the middle of the fucking night, and we're patching 1,500 servers for this company right now that you also work for. You need to open those ports right now, right? Like, because you guys, and like this is a real conversation I've had to have on like a bridge call, and then have to get people involved to like get these people to open the ports so that our devices can talk. And actually, I'm pretty sure, because that happened at least twice. I'm pretty sure that our team, and this is probably a call that I made or one of my old colleagues, Jason Brown, where we were just like, you know, fuck them. We'll set our servers to come off the main satellite, which is not optimal, but we're not going to fight with these guys, and we're just going to pull the packages that way. And I'm pretty sure that's what we did, because if your capsule can't update off the main satellite server, then the nodes that are going to it won't get the as you life cycle through. They won't be, basically the satellite main server was good, but none of the capsules had pulled any of the updates. So all the servers were thinking, hey, we're patched, we're good, buddy. And you're like, you're supposed to have like 400 patches and kernel patches, and then you're supposed to reboot yourself. But like our Ansible playbooks were just going, I'm good, bro. We're good. Patching must have been done already. But it's because there's a disconnect because the devices couldn't talk because firewalls have been dropped in between. So then you say, well, how does the server pull? Well, that's just a 443. So that was being allowed. Because when a server pulls, it's just a basic low communication pulling down his metadata and all that stuff. It's just not efficient. You're pulling it across the larger network, maybe even between data centers at that point in our case. And we said, you know what, F it. We're just going to, because again, these guys were being obtuse. We had the proof in the CMDB that we had asked for those years before. And you might say, well, why didn't they do them then? Well, because back then they looked at them and said, well, we leave them all open anyways. I'm pretty sure. So I don't know that anybody got fired for that. I do know like 2 other things networking guys got fired for that were real stupid. But anyways, that's, yeah, people do dumb stuff. But anyways, so who's causing the load? You should be able to look at the process ID and then look at it against the different CPUs that it's on. We were doing that yesterday. And then also what user ID it's tied to. So, you know, you're over here, and I think I have all the history here we were even doing. What was I doing it on? Might have been doing it on my Rocky 4 box. Yeah. I think I was doing, had a bunch of commands we were doing here. Yeah, we were doing mp stat. mp cat dash p all every 1 second. Oh, whoops. Dash cat p all. Yeah, and then this would show me what CPUs are running, and we were talking about how sometimes users think that their processes were spread out, but they're really just all running on one CPU, and that becomes very apparent when you look at stuff like this. Or you can do some of these other ones. PIDStat was the other one. And PIDStat was showing us what processes were running and were they balanced across all the CPUs or were they only on one CPU, and we could use this to kind of see what's going on in the system, right? So what's causing the load? Is there load? Where's the bottleneck? Is the utilization all the way up on CPU, memory, disk, or network? Those are the big four. And by the way, they saturate and run out in that order typically. What is the load? Is it IOPS? So that's reads and writes out of a block device. Is that where the load's high? Is there high load average going to the CPU? Is there latency for like queries across the network? Are you getting high errors on TCP? Are you getting TCP connections? We were talking about that yesterday, how if your server is not establishing any TCP sessions, but you know it's supposed to be doing TLS termination at that device, TLS termination has to occur over TCP. It doesn't happen over UDP. So, right, and we were looking at all these. So if anybody wants to see those, we were doing those all yesterday. But it was the same talk. I was in the same thing. And then how is the load changing over time? Is it spiking up and then dropping? Is it spiking up and staying high? Has it been high for the last 3 hours on one node but not others? We had one many years ago. I was working on a system, and if the queries on the production database ever went over 10 milliseconds, it was all hands on deck. And this happened like 5 times in my 4 years at this company. Big insurance company. 5 times over the years, it was everybody, like all the hands from all the teams, all like the leads and stuff. We were all in a room back in the day when we were all in a room together, and we had to fix, why is this database slowing down? This production database is down well under the service level agreement, because typically transactions were under 2 milliseconds in that database, and they were up over 10 milliseconds. What's going on? And all 5 of those times, and I had heard of many others, but all 5 of the times I was involved, it was because some developer had gotten and done queries against that database directly instead of one of the replica databases that they were supposed to. Every single one of those times. So where I'm going with that is load can change over time. Users are almost always going to cause it, because even though they're developers, they're still just users of the system, right? All right, anyways. This is the thing I was talking about, utilization, saturation, and errors. You should always look at that in your systems. So we covered this yesterday more. Stepping through the OSI model, if you can ping a device, you know that it's up, you know that its routing is working, you know all kinds of things. If I can get to a server here and I'm already SSH'd into it, that means it's working. But if I see its IP address is there, its IP route is there, and I SSH'd in, when I pinged it, those things had to be right for it to send me traffic back. It can't even send me traffic back if it doesn't have those things right. It doesn't know how, right? So that's important to know. And then, you can look at all kinds of other things. You can break all this down. You can pull up Wireshark and TCP dump stuff out to a PCAP file, pull it out and look at it in a system. You can send it over to your network team, let them look at it. There's all kinds of things that you can do. We did some of those yesterday. This one right here, this is what doctors do. So this assumes that you are an expert in systems, but not necessarily the system that you're on. What I mean by that is, if you were like an ear, nose, and throat doctor and somebody came in and said, my ear, nose, and throat hurt, you go, I've never met you before, but I bet you your ears, nose, and throats are pretty similar to everybody else's, so that's how we're going to look at it. Well, this is the same way. This is, you're good at systems and networking and that kind of stuff, and you can look at the symptoms of some problem, bunch of, we used to get a bunch of 200, like 99% 200 okays, and now we're at like 92% 200s with 8% of 400 errors. That's a problem, right? And 400 errors tend to be your client made a problem. Maybe it's 500 errors, so it's your server problem. Some server things happening incorrectly. Then we identify the most likely cause. Well, if there were 8 servers and I saw let's say there were 8 servers and there was 12% of the problems. I would probably think one of those servers was having problems behind a load balancer, or load balancers are what are commonly called reverse proxies. By the way, sorry, Kevin, I've been missing a lot of stuff. Can you look at monitoring event history? When you do, is there a pattern? Say every Tuesday night at this hour, the same thing happens. That's a good place to start too. Yeah, Kevin, I use an example of that comes up a lot. I remember there were a few questions like this on the Solutions Architect Pro when I took that and passed that 3 years ago. I think that's about to run out for me. But anyways, on that one, they always talk about like Friday afternoon, your gaming company's server usage goes up. Well, everybody's off of work. All the kids don't have school the next day or homework, so they can just play video games all night. So that's when gaming companies have their server usage spike, right? That's that kind of stuff. So anyways, this is the idea of symptom diagnosis and then getting to a solution. Treat it. Try to solve that problem. If it doesn't, come back up here and go through the process again and again and again. This is a simple one to understand, but you have to be an expert in systems for this one to work. So this one leans heavily on knowing how all those tools work, knowing what a good healthy server looks like, not for that specific environment, but servers in general. Now, this one is systems thinking. Systems thinking assumes you're an expert in systems and you're an expert in this particular system. So you need to know those two things. So this is the process of analyzing all interdependent components that comprise of a system. Let's say that you went to prolug.org and prolug.org was down, right? Let's say it was down. Go to my Excalibur. Let's see if I've pulled this one up here before. That's not it. Let's see if I have this scene. That was somebody asking a question about something else. That's something else. That's something else. I want to see if I have. That's something else. I might not have it out here. I might not have it on Excalibur. Hold on. I definitely have it over here. I just wasn't sure. Let's go look for it in. So here's how. Let's fix this. Background zeros. And then let's go over here, Control A, and let's move those to white. There we go. Okay. So just so it's a little easier for you to see. Well, so Cox Internet blocks port 80 for me. I don't know if you guys know that. That's a fun little proclivity of not paying them for like I just have a normal house line. So they block port 80 and they block port 20. Well, any of the IMAP protocols, which I think are like 90 and 113 or something. I don't know, whatever. They don't let you run your own mail server at home. I don't know if you guys know that, but that's how some internet providers do it. And it's funny because they don't tell you that anywhere. You have to just know that. But anyway, so the way we do the home, so let's say that I knew something was wrong with, you went to prolug.org and you couldn't get to us. So where would I go start looking? Well, I know that we deploy inside of a K8s cluster in my home lab. And then we have an external service out of that cluster that can be reached from my external router. And that external router on port 8080 connects back to that port 31000. But you don't get directly to either port 8080, because on the web you're coming in on port 80 typically. Your system, if you put an 88 after, you actually could test to our Prolug, but that wouldn't be the way you'd want to connect, because you really just want people to be able to go to like prolug.org and get directly to us. So what we have is a CloudFront cache out there. So CloudFront is an AWS service that just acts as a cache in front of your web page, and that actually goes and downloads our page for us and keeps it up there and provides it to any of you guys that want to get to it off the internet. So if you come to my page here and it's broken or down for any reason, you're actually hitting a CloudFront cache, right? And then if I were to go to like certify and verify, and I were to check for Scott Champagne here, that's me, and I wanted to see my professional Linux users group cert, and this cert number right here, by the way, I could like put on a resume and then this would show up for anybody. This is for people that go through our courses and certify. They all get one of these. Everybody's got one of these, and it's all tied back to exactly them. So then if somebody clicks on it, it at least takes them over here and says that they completed this course with us back in whenever they did it. All right, anyways, I pulled that all up to show you that systems thinking is a way of troubleshooting all of that. If something was broken, I could go check each individual piece until I got it all working. And the main question there is, how does the data flow? How does the system work when it is working? And if it's not working, where does it go to? I grew up in Phoenix, and a lot of people probably don't think about this, but Phoenix, Arizona is actually very good for citrus and very good for cotton if you can get water to that area. And you go, but it's a desert. And I say, yeah, but did you guys know that the Hohokam used to live out here? And they were a native tribe that had canals. They built canals all over the place. So even to this day, well, those canals don't exist anymore, don't get me wrong, but even to this day, the model of canal, the angles and everything of it are still used from back with them because it's the most optimal way to move water. Well, we have canals all over in Phoenix. And when I grew up down by the farm area, which was out by Luke Air Force Base. I would watch how they would irrigate. They flood areas and then they open these gates and it floods out to the next area. So if you've never seen that before, that's exactly how I think of system data. That's exactly how I think of like when we do monitoring data. If you guys have seen my monitoring stuff before, like how the data flow within the system. It's almost like you're just plumbing the interface up and all the data starts flowing, right, the way that it's supposed to. So anyway, so that's systems thinking. And then we get into, this is more like engineering, and as we're building things or planning to build things, but failure modes and effects analysis, FMEA. It's an old government technique to figure out what could go wrong, what impact will it have if it does go wrong, what's the likelihood of it occurring, and what's our ability to detect and react to it, right? And this is a lot of these things, if you're just planning them and kind of designing them for the first time, they're going to be qualitative in nature. There's no numeric value to them. I can't do anything with it if it's qualitative. It's like, well, that's bad and that's bad, but what's more bad? Well, I have to have a way to quantify things to be able to say, well, this goes higher or this goes lower priority. So there are 2 steps to it. We're going to round up all the possible failures that we know of, and then we're going to assign scores across 3 different areas to get what's called a risk priority number. So it looks like this, right? And I'm not going to go into this. I have other talks where I actually have dug into this heavily, but this is a real one that I used to run into. These are all real. There's probably about 20 more of these, but when we used to do server builds at AAA back in the day, these were where the things could break. They're just a bunch of things that could happen. A bunch of different failures that occurred or could occur in a system, right? Oh, I got all kinds of messages and stuff. People trying to text me and all kinds of stuff. Okay, so what we do is we take all of those and we do severity times probability times detection to get the risk priority number. So the risk priority number here for customer impact or severity is a number between 1 and 10. And the probability or likelihood is the number 1 through 10. And the number detection or detect and react is the number 1 through 10. So let's do a quick little exercise real quick. If I had 1 times 1 times 1, what number would I get? And if I had, at the far side of it, 10 times 10 times 10, what number would I get? Because with that, we can determine what's called the range. We can know all the possible values that something could fall into. That's our range of output, right? So when we put numbers into this, we can have a risk priority number from 1 to 1,000. That's exactly correct. That's why none of them can be times 0. You can't have a 0. We didn't do 0 through 9. We did 1 through 10. Because 0 would cause everything to become 0, and it wouldn't matter what the other 2 numbers were. With 1 being the base number, the lowest number we can have is 1, and the top number we could have is 1,000. And that's very useful then, because now we can say that this is going to be our highest risk priority. So assuming, and there's other considerations that start to come in, especially in the business sense, where we talk about financial or hours and effort, what we call level of effort. But just looking at this part of it, this is the thing that carries the most risk. This thing has to have priority. All right. And I've talked about what all these actually were in other talks, and If somebody wants me to do that sometime, I will. But I don't have too much more time tonight because I think the wife's all done with doing what she was doing. Actually, let me text her and say, when you're done, just give me a message. Text me. See what she says. Also, the son missed school today, so that's not good. The school always texts me when he misses school. So, all right. A few other notes on troubleshooting. There's a whole bunch of them. I want to get more in here and put more of these up. But I think you should avoid talking about your feelings. Your feelings are irrelevant in engineering. I'm not saying you can't talk about your feelings outside of a trouble call or an incident, but I just don't think you should talk about it during them. Now, you could say that this has similar behavior to another thing that it's not good to say this feels like another problem we've had. That's not useful. I can't get anything from that. But if you say this is similar to that other problem that we had in that it was slow disk, Scott, can you go check the IO? And I go find that, yeah, your Java process is thrashing on one box. Boom. Now that is useful. But just saying, this feels like something, that's not good. It's the same thing that I was saying, and I know people be like, oh, that's a bit pedantic. Well, when we're dealing with accuracy and precision, we want to be as accurate and precise as we can. I don't, I tell you guys sometimes, like when I talk and I lecture kind of like I am now, or I do with my college students, I'm not up here talking because I want to be smarter than everybody. I don't care who's smartest in the room. But this might be the only time you get to hear how an engineer talks. So I'm going to let people know what these, what it's like to sit around and talk with other engineers. And I know I sound like an engineer because I've been doing it for 25 years. So it's not me trying to sound like it. It's me showing other people. Again, because some people break rocks for 40 hours a week, and this is the only time, or in my college classes, the only time that they can hear this. I'm going to try to provide that for them, because I always say I hope this stuff's valuable to you guys, because why would I waste my time and your time, right? Anyways, another one, avoid all anti-methodology. So the blind man, you just start changing things at random until something happens or something fixes. That's a really bad thing, because especially if you're changing more than one thing at a time, because then when the problem disappears, you're like, whoa, what did you do? Well, I don't know. I was doing stuff, and the networking guys were doing some stuff, and he was doing some stuff, and he's over here doing some stuff, and well, it's good. Let's go to bed. That's a time bomb waiting to happen, right? Me literally thinking about you breaking. I did roofing when I was a kid. So in my teens, my uncle owned a roofing company, and I went and did roofing with him every summer in my teens. So I definitely have broken rocks, although it was more carrying stuff up, putting it on a roof. Spotlighting is only using tools you're familiar with. Now, obviously, you only know the things you know, but this is the idea. Like, if right now you said, hey, Scott, I saw that stuff from Brendan Gregg that you showed, and I saw some of those other commands. I've never used a single one of those. I would say, okay, here's your goal then. If let's say you got an interview in 3 weeks, and they're going to ask you Linux troubleshooting questions. I would say, hey, you need to get 20 minutes a day at least hands-on practicing those. There's a bunch of lab places you can go figure that out. We've got lab environments you guys can play in, but you've got to go do those commands. Even if you're just typing the commands like I did, just to see them run in the environment. Even if it's just to be able to say, well, even if it's just like that while we're talking here, like it's just something running so that I can kind of get a feel like, if I were to look at this right now, there's something that's very glaring here to me. If this was a box that was supposed to have users on it, like it was a dev box, every single process running here was started by root. Do you guys see that? See this line, this value right here? That's super strange. If you're doing user support type stuff and you're like getting your devs onto a box where they're going to do development work, or it's like one of their dev clusters and you expect 30 or 40 people to be on there, but there's no processes. Every process here was started by root. Even me SSHing in there is root. That's anomalous on a system where you're trying to help users connect or whatever, or if a user asks to get connection to a system and you go check and no user's ever logged in on the system before, the user may be asking for something they're not supposed to have according to their team. Somebody might have been trolling them and told them to go ask the Linux guys for something, or told them to put in a ticket or whatever. People do that stuff too. But anyways, Another one. This is one I'm big on. Don't just go blame networking. Networking knows it's their fault. They know it's DNS, right? But you can't just get on there and start pointing fingers at them. You're gonna have a lot of angry network guys, and they're not gonna work with you. And I had people on my team that the networking team would not work with, and they would come to me and be like, Scott, I'll work with you, man, but now you got to take that. And I'm like, oh, all because this person just doesn't know how to talk to the networking guys or whatever, or they had dealt with them enough, and they're like, I'm not going to work with that guy. And I'm like, all right, screw it. But anyways, my point is that you can get, and you say, no, that's not a real thing. I'm going to tell you right now, the problem in the IT space is very rarely technical stuff. It's almost always people to people interactions, if we're being honest. All right, anyways, questions, drop them, chat and Discord, that kind of stuff. This talk again is all up there. So if you guys want that, it's up there. I should probably get off of here because the wife just texted me she was making dinner. But let's go to our little end of stream. I appreciate you guys hanging out. We have talked the last couple days about getting into the Linux field. If you want to, we always have a little Discord here. Let me pop the Discord up for people that want it. For you guys over on the YouTube side, it's down in the subject or whatever. But the thing about this is, you just have to spend time. I can't spend time for you guys on this, right? I can't do a lot of this stuff for you. You guys have to spend time yourself, and the stuff that you see me do, you'll forget. So you have to go spend time. We did have somebody else running. Some other UID was doing something, but very rare. Very rare. We can go see what that UID is, but yeah, this is RPC. Yeah, okay, RPC bind. That's the only other process on the system than all root. But anyways, I didn't even realize that aggregated either. That's awesome. It aggregated all the processes up at the end and told us how much they were doing on the system. So yeah, so I appreciate you guys coming by. I'm gonna drop off of here. Let's go find, well, we don't need to raid anybody. We only got 18 people. Well, let's see if anybody's on. I was gonna say we don't bother raiding anybody tonight. Yeah, we don't have anybody. Oh well, Midnight Simon's on. We can go raid Midnight Simon. I'll go raid over there.